Bismillahirrahmanirrahim. Assalamu alaikum. Myself Dua Shehbaz and I am from the Aspire Technology Department. Today I am here to present the chemistry of some compounds like 2-naphthylamine and 1,5-disulfonic acid. To start every topic, first of all, we see contents. Contents mean under which headings we cover our whole topic. Here we have the contents like introduction, preparation, properties, and we all know that there are two types of properties is in chemistry, that is physical or chemical. Applications, summary, and references. We start with the basic introduction of 2-naphthylamine. 2-naphthylamine in one of the two isomeric amino naphthalene compound with the formula C10H7NH2. It is the colorless solid, but samples take on reddish color in air because of oxidation. Oxidation is the addition of oxygen, removal of hydrogen, and loss of electron. It was formerly used to make azodyne, but it is known carcinogen and has largely been replaced by less toxic compounds. And here is the question, what is azodyne and also what is carcinogen? Azodynes are the organic compounds that are widely used to treat textile, leather articles, and some foods. And carcinogens are the agent that has the capacity to cause cancer in human. This is the structure of 2-naphthylamine, and we've seen that amino group is attached to the second position. That is the why it is called 2-naphthylamine. Here is some important points about 2-naphthylamine. A naphthylamine carrying the amino group at position 2. As we discussed above, that amino group is attached to the position 2. Its IUPAC name is naphthalene 2-amine. It is also known as beta-naphthylamine. And here is the 3D structure of 2-naphthylamine or beta-naphthylamine or naphthyl 2-amine. These are the different names of 2-naphthylamine. Here we have the preparation method. 2-naphthylamine can be prepared by the Butyrier reaction in which 2-naphthol, which is also known as beta-naphthol, is heated at 200 to 210 degrees Celsius in the presence of ammonium zinc chloride. Each acetyl derivation can be obtained by heating the 2-naphthalone with ammonium acetate to 270 to 280 degrees Celsius. And here is the reaction, and we see that the beta-naphthol is heated in the presence of the NH3 or NH4HSO3, and we obtain the product which we call beta-naphthylamine or 2-naphthylamine. Here is the few description about the 2-naphthylamine. 2-naphthylamine absorbed by skin, mouth or lungs, oxidized in liver to 2-amino-1-naphthol, immediately conjugated with glucuronic acid exerted as glycuronidase in urine. The glycuronide is hydrolyzed in urine by beta-glycuronidase to liberate the carcinogenic 2-amino-1-naphthol. As we discussed above, that there are two types of properties physics in chemistry. One is physical properties and other is chemical. First of all, we discuss the physical properties. Physical properties are the characteristics that do not involve in change in sample chemical characteristics makeup. And here we have these some physical properties. Molar mass. Its molar mass is 143.189 gram per mole. Appearance is white to red color. Odor, it is odorless. Its vapor pressure is 1 mmHg, 107 degrees Celsius. Density, its density is 1.061 gram per centimeter cube. Boiling point is 306 degrees Celsius. Its melting point ranges from 111 to 113 degrees Celsius. Solubility in water, it is miscible in hot water. On the other hand, now we discuss the chemical property. It gives no color with iron 3 chloride when reduced by sodium in boiling a mild alcohol solution. It forms tetrahydro-3-naphthylamine, which exhibits the properties of the aliphatic amine in that it is strongly alkaline in reaction, has an ammoniacal odor, and cannot be diazotized or oxidation. It yields orthocarboxyhydrocenamic acid. Numerous sulfonic acid derivations of 2-naphthylamine are used in commerce as a precursors to dyes. Now we have the applications related to this compound. 2-naphthylamine formerly was used commercially as an intermediate in the manufacturing of dyes, as an antioxidant in the rubber industry, and to produce 2-chloronaphthalene. Small quantities of 2-naphthylamine are used in laboratory research. This substance has been found as contaminant in other chemicals and industries. It is used as antioxidant in rubber industry. Now we have some hazards related to 2-naphthylamine. 2-naphthylamine is found in cigarette smoke and suspected to contribute to the development of bladder cancer. This is why it is also known as carcinogen because it causes cancer, especially the bladder cancer in humans. It is activated in the liver but quickly deactivated by conjugation to glycuronic acid. In the bladder, glycuronidase reactivates it by deconjugation, which leads to the development of the bladder cancer. Now we have the summary. It has many advantages like it is used in drugs, pharmaceutical industry, etc. Studies of cancer in humans exposed to 2-naphthylamine were most recently reviewed by a working group in 2008. It was concluded that there was sufficient evidence in humans for the carcinogenicity of 2-naphthylamine in the human urinary blood. Now we discuss the chemistry of our other compound, which is 1,5-disulfonic acid. Same, we start with the basic introduction of 1,5-disulfonic acid. Armstrong acids, naphthalene 1,5-disulfonic acid is a fluorescent organic compound with the formula C10SO3H2. It is one of several isomers of naphthalene disulfonic acid. It is colorless solid, typically obtained as the tetrahydrate. Like other sulfonic acids, it is a strong acid. And here is the 3D structure of 1,5-disulfonic acid. Some important points about 1,5-disulfonic acid. Its IUPAC name is naphthalene 1,5-disulfonic acid, other name Armstrong. And here is the structure, and we see that sulfonic group is located on position 1 and 5. This is why it is called 1,5-disulfonic acid, naphthalene 1,5-disulfonic acid, or Armstrong. And these are the different names of the 1,5-disulfonic acid. Now we have the preparation method related to this compound. It is prepared by desulfonation of naphthalene with oleum. C10H8 is basically oleum plus 2SO3, and we obtain the product C10SO3H2, and which is basically the 1,5-disulfonic acid. For desulfonation, give the 1,3,5-trisulfonic acid derivative. Here is the graph related to the 1,5-naphthalene disulfonic acid, which discuss the following factors like column size, mobile phase, buffer, flow rate, and detection. As we discussed above that there are two types of the properties like physical and chemical properties. First of all, we discuss the physical properties. Molar mass 288.299 gram per mole. Appearance, it is colorless solid. Purity, it is 96% purified. Physical form, it is in the form of the powder. Chemical properties, fusion of Armstrong acid and NaOH gives the disodium salt of 1,5-dihydroxynaphthalene, which can be acidified to give the diol. The intermediate in this hydrolysis, 1-hydroxynaphthalene, 1,5-sulfonic acid, is also useful. Nitration gives nitrous disulfonic acid, which are precursors to amino derivatives. The disodium sale is sometimes used as a divalent quaternion for forming salts of basic drug compounds as an alternative to the relative mesylate or the prosylate salts. Here is the application related to this compound. Detergents and similar products like soaps use sulfonic acid to break down this sulfur tension between water and grease, dirt and other grime for a more effective clean. It is also used as catalyst for carrying out many organic reactions. It is also used for making adhesive ion exchange resins. And at last, we have the assembly related to this compound. The sulfonic acid are among the most important of the organosulfur compounds. The free acids are widely used as catalysts in organic synthesis, while the salts and other derivatives form the basis of the manufacturing of detergents, water-soluble dyes, and catalysts, sulfonamide pharmaceuticals, and ion exchange resins. Here is the references from I collect the description of these two compounds, which is naphthylamine and 1,5-disulfonic acid. Thank you for your attention. Have a nice day. Allah Hafiz.